Hello class, so we are looking into August 2009 questions. Alright, so let us go through these questions together. So here we have the picture, and when you look through the choices, they're all about parallel. When you look into that, we realize that this is 60-degree angle. But not only that, this is also 60-degree angle because supplementary of 120, which makes these two alternate angles. Since they're congruent, we realize that line segment D and E must be parallel to each other. Here it goes, number 4. Now, next. This is a construction from this point having the same length, the line segment, and then cutting it across. This in fact talks about the angle bisector. That means this portion of the angle must be equal to that portion of the angle. So anything that says that would be our answer. Angle DBF right here is half of angle ABC, which is correct. This is only one portion out of the two portions, then therefore this must be half of it. Alright, angle here is equal to 40 degrees, but AB is equal to AC. That means this is also 40 degrees. Then you can figure this one out quite by 180 minus 80, because we have 40 and 40, add them up. Then we have 100 left. So 100 becomes our answer. Right over here. Now here, our measure of the arc AC is 30 degrees. Then since these two are parallel, then we realize this is also 30. So that makes the arc CD be quite easy, because when we add them up, 30 plus x plus 30, due to the whole thing being diameter, right here, A or B, must be equal to 180. That makes x to be equal to 120. So choice 2 becomes our answer. All right, number 5. Trapezoid here, diagonals intersect at E's, and then triangle ABC. AB, which is that triangle. The red triangle is equal to DCB, the blue triangle. Now, which statement is true based upon the given information? AC must be congruent to, not BC, but rather BD, so that one's out. CD and AD, CD, which is right here, CD is here, but AD is here, once again, that's not corresponding part. Angle CDE, CDE, which is this angle, in fact, is equal to BAD, BAD, oh, that's not quite the same. That's also out. CDB, CDB, that angle is equal to BAC, BAC, that portion of the angle. That is correct. Due to CP, CTC. Alright, number 6. The figures are similar, then directly tells us about the dilation. Only thing that's possible is choice number 2, but not congruent to the original figure. That's right. So therefore, dilation of the factor that's besides 1. Now, number 7. Here, angle 1 is 45 degrees. And then DCB, the whole angle here is 120. But in a parallelogram, the two consecutive angles are supplementary. That means 45 plus measure of angle 2 plus 120 must be equal to 180. Now here then, measure of angle 2 is simply 15. Therefore the answer is 15. Alright, so this basically means we are looking at the translation of 2, 1. When you translate any figure and then reflect it about the x-axis, reflection and then translation, they don't change the area at all. So therefore, our answer would be exactly 28 units. Alright, next. Parallel, that means the slope here is equal to 1. The slope has to be the same. So I'm looking for another one that has the same slope. Here we have, where as x goes over to the other side, the slope becomes -1. But here, as x goes over to the other side, our slope becomes +1 because this becomes y equals x minus 1. And that becomes our answer. Alright, so we have C is midpoint. How do you find the midpoint? That's the average. So we get -2 plus 6 divided by 2. That's the first point. -4 plus 2 over 2 is the second point. Here we have 2, comma, -1. That becomes our final answer. Number 11. Center is the opposite of the sign here. Then center would have been 3, comma, -3. Notice the signs are the opposite. X is associated with -3. Then now we have +3. +3 then associated with -3. And this is r squared, so therefore radius here must be equal to 6. So therefore anything that has this one would be our answer. Choice 1. Alright. What is the point? Solution of the solution here, that means we just have to get the same value of x and y. Now, so let's try to do this one with the calculator. They're more convenient. So clear. So x squared minus 6x plus 10. That's the first equation. Second one is by subtracting x from both sides, we end up getting y equals -x plus 4. -x plus 4. Now we can do the zoom standard number 6. Okay. Something seems to be up. Alright, so we get an equation like this. So what we're going to be doing is this second trace to calculate intersection right here, number 5. First curve, second curve. Let's go near. I guess first line is 2, 2. So the one that has 2, 2 would have been this one and this one, but we don't know about these two portions. So let's look at the second point. Second trace once again. Intersection seems to be 5. So first curve, yes. Second curve. Guess we just have to go a little bit further in to find the second value. It was about 3, 1. So therefore, our answer must be choice number 4. Alright, so here we have diagonal AC is drawn in parallelogram ABCD. So we have parallelogram right here. A, B, C, D. Diagonal AC is drawn. Now, which method cannot be used to prove that those two triangles are congruent? Oh, wait a minute, even before we do anything, we realize SSA is not a valid way to prove two triangles are congruent, so therefore our answer is choice C. Alright. Now, which statement is true? Here we have line K is perpendicular to plane P, but at point T, you see it has to go through this particular point. Therefore, any point on the plane P is also will be on line K. That's not really true because a point can be around here or any other places for that matter. Only one line in the plane P will intersect with line K. In fact, no. I could have one line, two lines, infinitely many lines may cut across the perpendicular point. So that's not true either. All planes that intersect plane P will pass through point, pass through T. Once again, not true because, but any plane containing line K is perpendicular to plane P. That will be correct because if I have any plane that cuts across this way, must be always perpendicular to plane P. So that will be our answer. Number 15. How do you go from here to here? So if you have to move this one, so what I'm going to do is this. I will move this one to the front a little bit. That will be the translation. But if you reflect this one up and down, then you would have gotten something like this. So therefore, our answer will be glide reflection. Now, which set of numbers represents the length of the side of triangle? In fact, then sum of two sides has to be greater than the third. Only thing that's possible here would have been choice number 2. Sum of these two is greater than number 22. Alright. Next one. Slope has to be perpendicular. That means it has to be negative reciprocal of this one. So negation of negative becomes positive. Reciprocal of that becomes 3 over 2. So positive 3 over 2. Choice number 4 becomes our answer. Alright, so number 18. Diagonals bisect each other. This basically means parallelogram already. The perpendicular, that means a rhombus. This is through the memorization of properties of parallelogram. Alright, let us look at number 19. So length, we have to use the distance formula. So D is equal to square root of x1 negative 4 minus 2x2 squared plus, almost like a Pythagorean theorem right here, 5 minus negative 5 squared. Then here we have, this one is 6 squared, which is 36, plus 10 squared, which is 100. Therefore, this becomes square root of 136. But square root of 136, in fact, 4 goes in both of them. Square root of 4, and then this one becomes 34, which ends up being 2 square root of 34. That becomes our final answer right here. Choice number 1. Now here we have, since AC is 10, then this becomes 5. AT is equal to 18. That makes this one equal to 9. Oops. Wrong one. This one equal to 9. And CT is equal to 22. That makes this one to be 11. But we're looking for the parallelogram CDOG. CDOG, that means we don't need this one. So this one becomes 11. Opposite of 5 also becomes 5. So therefore we end up having 32 as our answer. Alright, next one. Number 22. So here we have a center at negative 5, 1. And then radius seems to be about 3. So that makes this one to be our answer. Sine has to be the opposite of its center, and radius has been squared up. Alright, great. Let's look at number 22. Here, the ratio, in fact, we're looking for this one, so therefore we have 12 squared. That side is equal to same side line segment, which is equal to x times the whole thing, which is 36. That means 144, which is equal to 36x. X here, when we divide by 136, we end up getting 4. So 4 becomes our answer. Alright, number 23. DE is equal to 2x plus 8, and EC is equal to 3, and AE is equal to 4x minus 3, and EB is equal to 4. So when we do the product of the two opposite sides of a same chord, and we get 2x plus 8, whole thing multiplied by 3 must be equal to 4 times 4x minus 3. Then here we have 6x plus 24 must be equal to 16x minus 12. As we subtract 6x on each side and adding 12 to each side, we'll end up getting 10x is equal to 36. Hence, x must be equal to 3.6. Right here. Alright, number 24. Negation. Simply, we just have to put the not. The squares are not parallelogram. That's basically what we're looking for. Then, which one is that? So it is not the case that squares are parallelogram. Simply, then, case choice number 3 would be our final answer. Here we have, these are the perpendicular bisectors right here. Right here, and right here. That means here what we, and then also this becomes circumcircle because the circle is outside, which is the intersection of perpendicular bisector of 3 sides. So we have choice number 4 becomes our answer. Number 26. Right circular cylinder has a volume of 1,000. So 1,000 is equal to pi. R is what we're looking for, r squared, and height becomes 8. Then yes, we need to divide by 8 pi. Then pi cancels out, 8 cancels out. Notice how we're going to put that into a calculator. So 1,000 divided by parentheses 8 pi. In that way, we realize whole 8 and pi will be dividing. But here we have to square root it. Square root the previous answer. That becomes our final answer. So our final answer becomes 6.3. That's answer number 1. Right, number 27. The two different lines are perpendicular to the same plane. If we have a plane, two different lines are perpendicular, one here, another here, that means they must be parallel. In other words, parallel lines can be always coplanar. Meaning these two lines can be placed in another plane. Alright, number 28. How many common tangent lines can be drawn? So here, one line which we can draw would have been this way. Another line would have been right over here somehow. Third line will be somewhere in the middle. Therefore, our answer will be 3. Alright, here we have isosceles trapezoid. That means these two sides must be equal to each other. So we have 2x plus 5, which is equal to 3x plus 2. Then when you subtract 2, you subtract 2x. And we'll end up getting x equals 3. I guess we found the value of x. How do you find the volume of the pyramid? It's 1/3 base area times the height. 1/3 base area, since the base is equal to 12, So we're going to have 12 squared times the height. Height is equal to 42. So then that becomes our answer. So we have 12 squared divided by 3. But we gotta multiply that by 42. Multiply by 42. So 2016 becomes our final answer. So, number 31, we have parallel. Okay, that means gotta have same slope. So let's try looking into this one. So, subtracting 2x, we will have negative 3y equals negative 2x plus 11. Now, by dividing by negative 3, y equals negative negative becomes positive 2/3. X minus 11 over 3. But what we are concerned about is the slope, which is 2/3. With the passing by this point, then we will have y minus negative 5 equals 2/3 x minus 6. This will be point slope form. So essentially is equal to y plus 5 is equal to 2/3 times x minus 6. That becomes your final answer. Alright, number 32. Angle bisector. Okay. Here we have and first draw a line like this, and from that line I guess we can draw another arc, and we can draw another arc. Then we see that it matches right over here. Then we can bring out a ruler and then we can go to the point of intersection and draw a straight line right here. Then that becomes the angle bisector. Alright, number 33. So these are the measures of the angle. Then what we can do is simply add them up. X plus 3x plus 5x minus 54. That must be equal to 180 degrees because it's a triangle. Then we have 9x equals to 34. Then x can be equal to 26. So when we have 26, then I guess we're done. Yeah. Now here we have, as soon as you realize this picture, 37, 117, that this angle is simply, when you add up these two angles, you should be about 117. That means when you subtract 37 from 117, we'll end up getting 80. Now, what is the longest side? Longest side is the opposite of the biggest angle. Here, since this is 117, then this must be 63. The biggest angle is 80, that makes the AC to be the largest. Alright, number 35. Write an equation perpendicular bisector. So perpendicular, we need the slope. Bisector, that means we need the midpoint. The slope of this line is 1 minus negative 5, y2 minus y1, over negative 1 minus 7. So here we have 6 over negative 8, which is equal to negative 3 over 4. Slope of the line that's perpendicular would have been then 4 over 3. Now, second, we need to find the midpoint. Midpoint is almost like an average. Here we have -1, then 7, -1 plus 7 over 2. And then 1 minus 5 over 2. Then what do we end up getting? Left side becomes 3, the right side becomes -2. 3 comma -2. And using these two pieces of information, we should be able to find it, because y minus -2, that means y plus 2, which is equal to 4 over 3 times x minus 3. That becomes our answer. Alright, so here we have so y equals 3. Oops, my bad. Let's get the all points that are 5 units from the origin. 5 units away from the origin. 4 units, 5 units. Now, and then 2 units from the line y equals 3. Y equals 3, that means right around here. But 2 units from there, so therefore we're going to have one right here, one right here. So therefore our final answer will be that 1 point, and this one, and then this one. Total 3 points. Alright, so number 37 here we have just making 2 axes, and okay, so let's see, D was 1 comma 1, and then E was 5 comma 1, and G was 5 comma 4. So we have D, E was right here, and G. Now, rotating 90 degrees about the origin, 90 degrees, then that means you just go this way. And what's going to be happening is, in terms of values, you simply switch them and then negate the one in the front. So therefore, here we end up getting, oops, one comma 1 simply becomes this way. And then 5 comma 1, we simply actually just simply switch them and negate right here. We end up getting 1 comma -1 comma 5. So -1 comma 5, 1 right here. And then the other one is -4 comma 5. That's a G prime, E prime, and D prime. All right. The reason why they preserve the distance is, I mean, first of all, rotations doesn't change the distance, but if you have to find out the distances, what would have happened here is, here original distance was 3, here original distance was 4, which makes this one into 5, but after transformation, this one was 3 and this one was 4, and by the Pythagorean theorem, this side becomes 5 once again. So since the distances are the same before and after, hence it is distances has been preserved. number 38. Here, what we can say is first, AE, that means this line segment, and then the red line segment, and then FC. This line segment, the blue one, they are congruent to each other. All right. That means by reflexive property in the middle, we can say AF, that portion must be equal to CE by subtraction postulate. Now, then, angle 1 and angle 2 are also congruent to each other. That's given. And BF is perpendicular to AC, which makes this angle to be the right angle. So is this one to be the right angle. Then we have angle, side, angle, side by these two triangles to be congruent to each other. Now, knowing that, then we realize this side is equal to this side. Not only that, we realize that angle is also equal to this angle by CPCTC. But when you realize that these two angles are congruent, then these are alternate interior angles between the line AB and CD. Therefore, line AB and then CD are also parallel. So when a pair of opposite sides are congruent and parallel, then it is a parallelogram. That's the last one which we could have proved. All right.